1.4 notes, we're going to be writing piecewise functions. This includes both the algebra 1 side of this, writing a equation of a line. Usually we use that y is equal to mx plus b. It's also going to involve the interval stuff we've talked about before, and we're actually going to help drive and start the conversation with that conversation about intervals. So we know that we have these piecewise functions. We want to pay attention how many pieces are there. To start off with, we also know from domain and range notes that we want to also pay attention to, are there any arrows? Finally, of course, before we're just starting to look at things, how about the included and excluded points? What does that mean for us as well? So there's a lot of things to consider. We're going to try to go ahead and practice that on these notes. So there's a couple things to going on right here. The first thing is might as well color coordinate some things for us. For instance, I could see I have a constant interval right there. I can also see that I have an increasing interval right there as well. So that's going to help me not only understand slope and the equation of a line, but also understand how that's going to travel, what that might mean for my my slope and the interval as it is. Second thing I want to pinpoint here is I want to pinpoint the arrows. All right. If we were having a conversation about domain and range, we know that means that we would be traveling to infinity or negative infinity. So if it's a conversation about the x value, that's a pretty big deal. All right. So we'll make note of where the functions start and end to dictate the intervals first. Here I see I have two pieces. So first thing is first, I'm going to go ahead and write out my good old f of x. And the equal to sign, we'll put it in function notation. We'll make this bracket right here. I'm going to try to make it as large as possible. And actually, now that I'm thinking about it, let me try to move it over just to give myself a little bit of space. And I'm going to go ahead and start with the blue. So what is the interval for the blue? Well, I can see that this is traveling all the way to the left. The arrow is pointing to the left in terms of that. Remember that in terms of intervals, I'm having x values only. So the fact that it's not going down, not going up, really not a big deal for me here. It's going to the left. It stops right here at a next value of 1, and it is an included dot. That's all really important to me. Let's go ahead and write out the interval. The interval would be, we're going x value to negative infinity. Remember, we're never going to quite get there, so we don't put a line underneath the arrow. X, and then we have an included dot, so that arrow does get a line, and it goes to 1. That is the interval. Didn't even start writing the function out yet. For the blue, let's go ahead and do the interval for the other function. Reading left to right, there is an excluded point. Maybe, there we go, excluded point at the number 1. And I do see this arrow traveling to the right. Now, of course, it's going up also, but the word up is a Y word. I'm doing intervals. I only care about left or right. So I know that the smallest scenario here for the green is the 1. I know that in an excluded point, so since it's an excluded point, I'm going to go ahead and put an arrow without a line. We're talking about x value since we're talking about intervals, and I am traveling all the way to positive infinity. So that is a way to write out that, I'm starting at 1, not quite going to be at 1, and I'm traveling all the way to positive infinity. Those are the intervals. Now let's go ahead and go and do the actual functions. I'm going to head back to the blue. What kind of line is that? That's a constant line. There is no slope. There is no rise. It's all run. So in terms of writing out the slope, there's nothing there. I don't have to worry about the mx part of this scenario. All I know is that in that situation, that equation of that line would be y is equal to, well, what is y equal to? Negative 4. So in terms of writing out this piecewise function, the first piecewise function is just going to be negative 4. And that negative 4, of course, goes from negative infinity all the way to positive 1. We do see slope. We see that increasing rate of change for the green one. So I do want to try to figure out slope. I can pick out any point I want. Find 2 of them specifically, of course, and count it out. And I could see fairly simply here, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Every single time I do that for my slope, I'm going up 1 and to the right 1, which means my slope here will be 1x. Unlike the constant interval, constant's flat, no slope, didn't have to write out a slope for that. Now, this is a part where people usually get tripped up a little bit because, I'm going to do a little bit of erasing here just to kind of backtrack. Right now, that is not touching the y-intercept. What we need to do is try to figure out what would happen if that line continued. When would it actually hit the y-axis? Now we know the slope is 1, so I can continue the same exact pattern, and then all of a sudden, bang, there would have been a dot right there. Now it got cut off by the interval. All right, but we can definitely see that if that line were to continue, it would have hit at the y-intercept of 2. I do want to write that down right here. So the equation of that line that we had highlighted in green is 1x plus 2, the slope being 1. It's got to be a positive 1 because it's an increasing interval. And the y-intercept would be 2. Our line's not currently hitting that, but we do have to make a little bit of an estimation. If the interval didn't cut it off, where would it have hit the y-axis?